Hello and welcome to the SAP Tech channel. Today, we're going to dive into a topic that is, and I'm not exaggerating here, absolutely critical for the security and reliability of any SAP landscape. We're talking about SSL certificate management.
Specifically, we're going to focus on the transaction STRUST SO2. Now, that might just sound like a bunch of letters and numbers, but it's basically the command center for your system's digital trust. By the end of this, you'll get how to use this really powerful tool to configure and manage all your SSL certificates.
So let's start with the problem, a super common, kind of frustrating error that I guarantee every single one of us has seen before.
You know the one I'm talking about, right? You're trying to get to a website, maybe it's even an internal company portal, and bam, your browser just throws up that dreaded not secure warning. What is actually happening there? Why is your browser suddenly saying, hey, I don't trust this connection?
Well, the root of this problem, a lot of the time, comes down to one single letter, S. See, standard HTTP is kind of like sending a postcard. Anyone along the way can just pick it up and read it. But HTTPS, that's like a sealed armored briefcase. That S means the connection is encrypted and it's been verified by a digital certificate, which is basically our guarantee that we're talking to the right server and that nobody is listening in.
So, how do we make sure all our SAP connections are using that secure armored briefcase method? Well, that brings us to the solution, which is built right into the SAP ecosystem, the SAP Trust Manager. And the key to this whole thing is that transaction code, STRUST02. The easiest way to think about it is like your system's digital passport office, or its trust manager. This is the one central place where you handle all the certificates your SAP system uses to prove its identity and, just as importantly, to trust other systems.
So inside Strust, you're doing a few core things. You're managing the life cycle of your certificates, and you're creating what are called personal security environments, or PSEs. Now, don't let the name scare you. A PSE is really just a secure digital wallet. It holds the certificate and its private key. It's this secure little container that lets you establish trust for all your secure connections, whether they're coming in or going out.
Now, to really get this, let's break it down into two key scenarios you'll run into. First up, when your SAP system is acting as the server.
In this situation, all the traffic is coming inbound. People or other systems are connecting to your SAP system from the outside. The most important thing here is that your SAP system has to prove its identity. It needs to hold up its digital passport and say, yep, I am who I say I am, you can trust me.
And you see this all the time. When a user logs into a Fiori Launchpad or an app is pulling data from an OData service, that user's browser is the client. Your SAP system is the server, and it absolutely needs a valid SSL server certificate to make that connection trusted and, secure.
So how do you get one? It's kind of a three-step dance. First, right inside SSL SO2, you generate a certificate signing request, or a CSR. This is basically the application form. Second, you send that application off to a trusted certificate authority, a company that verifies you are who you say you are. And finally, they send you back a signed certificate, which you then import right back into SSL SO2. And that's it, you're done.
Okay, so that's SAP as the server. Pretty straightforward. But what happens when the roles are flipped? Let's look at scenario 2, SAP as the client.
Here, the whole communication flow is outbound. Your SAP system is the one starting the conversation, connecting out to some external service. In this case, the tables have completely turned. SAP doesn't need to prove its own identity, it needs to decide if it can trust the server it's trying to talk to.
And this happens constantly in modern systems. Think about your SAP system calling a bank's API to process payments, or connecting to services on the business technology platform, or really accessing any third-party web service out there. In all of those cases, your SAP system is the client.
Now, when SAP is a client, there are two main flavors of trust to think about. SSL Client Standard is the high security option. This is for what's called mutual authentication, where both sides exchange certificates, like a secret handshake. But more common is SSL Client Anonymous. This is where SAP just checks the server certificate to make sure it's legit without having to show its own ID.
Okay, so we've looked at SAP as a server and as a client. Let's pull this all together and talk about the big takeaway here. Why is getting a handle on STRUST SO2 so incredibly important?
It really all just boils down to the direction of the traffic.
It's that simple. If the connection is inbound, with data coming into SAP, you need an SSL server certificate to prove SAP's identity. If the connection is outbound, with SAP calling out to something else, you need an SSL client certificate to make sure SAP trusts that external server.
And this is the real bottom line. This isn't just some small technical detail. When a certificate expires or it's not configured right, connections fail. Period. That means Fiori launchpads go down, API calls to your banking partners get rejected. In today's hyper-connected world, if the connection stops, the business stops.
We've definitely covered the essentials today, but there's always more to learn. If you want to do a deeper dive and get some more detailed guides and resources, make sure you check out the information I put in the description below.
And hey, if you found this helpful and you want to master some more essential SAP topics, do me a favor and hit that subscribe button for the SAP Tech channel so you don't miss our next explainer. Thanks so much for watching.